We are from Group 3, so this is our title, Factors Influencing Employee Attrition. So below are our group members. We have I'm Shin, and we have Shortway and Hong Jun. So I will move on to the introduction part. Employee attrition is actually referred to the employee turnover rate. So this can be a key issue in labor economics and human resource management when the turnover rate is too high, because it can impose some significant cost for the company or business, for example, like recruitment, training, and productivity losses. So this study we actually aim to identify the key factors influence employee attritions using the machine learning and statistical techniques to find out the most influential predictors for the attritions. So about the dataset, this dataset is actually from Kaggle, and the sample size is around 1,470. And the features, there is a total of 35 variables, including like attrition status, certification score, income level, and education, and so on. So I will move on to the methodology part. For the methodology part, so we have data preprocessing, result and discussions part. So data preprocessing, we have like data cleaning, feature selection, outlier removal, and normalization steps. So from here, you can have a look for the red words. Red color words means is the method that we use. For example, like we use in pandas, random forest, feature importance, IQR, min max normalization, and so on. While the result and discussion, actually we have the exploratory data analysis. Like we have focus on data visualization using the Seaborn and Matplotlib. And data modeling, we will using logistic regression and classifications, while the model evaluation, we're using the coefficient metric to calculate the model performance. So all of this, we will have a detailed explanation afterwards. So here we have the data preprocessing part. Firstly, I would like to introduce our dependent variable, which is attrition. Attrition is a binary variable as the result is yes or no. So from the descriptive here, actually we showing that the data set is slightly imbalanced because the majority response is no. So this might be causing some limitations for our further analysis that we will have a look in the further slide. As I mentioned earlier, our dependent variable is actually binary, and we also find out some independent variable is also binary. So the first thing we do is data transformation. We transform the binary variables into numerical. Then we're doing for data cleaning steps. So here we're using running some codes to check for the check and clean for the missing value and duplicate value. So the result shows that the data set is actually clean and no missing value and duplicate value. So there's no issue in this part. After that, we have our feature selection. So in this part, we running this is because there is too many variables for us. So this is quite difficult for us to focus everything. So we try to narrow our variables and just focus on the 10 top features, which is the most influential with our dependent variable, which is attrition. So after we running the random forest classifier, we have identified the 10 of them. And then after 10 of them, we will remove some unrelated variables or less informative, like the employee number. We remove them and then just lastly, finalize the six of them, which the table showing here. Here's the finalized 6 independent variable that we'll focus on. And at the right hand side, we can see we also run the correlation heat map to showing that there's really a relationship between x and y variable. So here we also have some steps to detect and remove our outliers. So the method that we use is interquartile range IQR method, because this is more suitable for HR data that can be skewed due to the varied employee background. So on the left hand side, we also have some box plot to visualize the outliers and or extreme values. So removal outliers is important for us to have more accurate model training for afterwards. So after the outlier remove, the result is shown as the green box plot graph here. The extreme value actually decrease, become lesser, and we also print out the data, the original data set. And after clean data set, there is like decreasing number in here. So they're showing some outliers removed. We're also doing some normalizations with the min-max normalizations to scales all the numerical variables between 0 and 1, ensuring the equal contribute during modeling. So you can see the result before and after here at the minimum and the maximum, showing that 0 to 1 lah. So therefore showing the normalization runs successfully.
Now, let's move on to the exploratory data analysis EDA. For the descriptive statistics, the data show an average employee age of 37 ages with moderate monthly incomes, a median of 10 total working years, and 5 years of service at the company. Approximately 60% of employees have left the organization, and most live close to their workplace. These findings suggest a workforce primarily in early to mid-career stages, where investing in career development, salary progression, and commute support could effectively reduce attrition and strengthen retention. For data visualization, the first one is the histogram. The histograms indicate that most employees have moderate incomes, fewer total working years, and live close to their workplace, where their age is more evenly distributed. This suggests a workforce largely in early to mid-career stages. Additionally, the histogram for categorical variables such as attrition and overtime only shows 2 bars because it represents a binary classification, which is yes or no. The second one is the scatter plots. The scatter plots show positive trends for age and total working years, where higher values correlate with higher income, and most attrition cases occur at lower income levels. No clear pattern is seen for distance from home and years in company. Well, overtime, which being binary, produces no meaningful scatter plot result. Economically, this suggests lower income, less experienced employees are more likely to leave, highlighting the need for targeted retention strategies. Next, the box plots show that employees who left represented by attrition equal to years tend to have lower income, are younger, and have fewer years of experience and tenure. Overtime was excluded because most plots are suitable for comparing continuous numerical variables across categories like attrition. Economically, improving pay and career development may help reduce attrition. Lastly, the line plots show that employees will stay generally on higher money income as their age, distance from home, total working years, and years at company increase compared to those who left. This suggests that long tenure, more experienced employees tend to receive higher pay and are less likely to leave, highlighting a link between income growth and retention. The variable overtime was not included because line plots are intended for visualizing trends between continuous variables. Including overtime in the line plot will not reflect meaningful trends. Economically, the result implied that rewarding experience and loyalty with higher income will help reduce employee turnover. Moving on to the identify trend, pattern, and potential relationship. The analysis reveals an attrition rate of 16.12%, indicating that approximately 16 out of every 100 employees have left the company. In terms of income, employees who remain with the company have a higher average monthly income compared to those who left. In conclusion, the economic implications of the data analyzing is the data indicates that the attrition is highest among younger, less experienced, and lower paid employees. Therefore, investing in career development, pay increases, and commute support can improve retention. Additionally, rewarding tenure and experience with better compensation help reduce turnover, resulting in a more stable and productive workforce.
So now we'll be moving on to the data modeling. So the first model we use is the logistic regression. So in this result of the logistic regression, we get the overtime is having the highest positive impacts on the employee attrition, which means that the higher the overtime, the higher the ones of the employee leave the job. And in the opposite, the job satisfaction is the highest negative impacts on the employee attrition, which means that the lower the job satisfaction, the higher the attention of the employee wants to leave the job. And one more thing is the monthly income is having the minimal impacts on the employee attrition based on this logistic regression. Beside the second model we use is the random forest classifier. So in the result of the random forest classifier, the monthly income become the highest impacts on the employee attrition, while followed by the age, the years at the company, the job satisfaction, and the least impacts on the employee satisfaction is the overtime. So now we will be moving on to the model evaluation for both model. So in the first model, which is the logistic regression, the model performed well in identifying employees who not left, which is attrition equals to 0, with a recall of 100% and F1 score of 0.93. However, it performs poorly in identifying employees who have actually left, which is attrition equals to 1, with a recall only 0.03 and F1 score of 0.05. So this is heavily biased towards the majority classes, which is no turnover employee. So this model perform will miss most of the attrition cases, so they suggest to use the class weight in logistic regression to give more weight to minority classes, or use the random forest to handle the class imbalance. However, for the second model, which is the random forest classifier, we found the overall accuracy of the model is 85% of the time, and it also gives a high precision as all employees predicted to leave, which is 78% actually did. However, there's a low recall as the model only correctly identified 11% of those who left. There is also a low balance between the precisions and recall as F1 score is only 0.19. So the random forest classifier is powerful and accurate, but it has some limitation also. It may overfit the training data if not properly tuned, and it might struggle with imbalanced data where very few employees leave. To improve the model, we can fine-tune its setting like tree depth or number of trees, use technique to balance the classes, and possibly combine it with simpler model to improve the interpretability. So in conclusion, overtime is the strongest predictor of attrition, while higher job satisfaction, age, income, and tenure reduce the likelihood of employees leaving. So the logistic regression perform well in predicting who will stay, but struggle to identify who would leave due to the class imbalance, same as the random forest classifier. So to reduce the attrition, HR should focus on managing workloads, improving the compensations, and offering career development opportunities to the employee. So that's all from us. Thank you.